This video is on slope and rate of change. We're going to find the slope from a table. So we have three examples here. We need to remember that our slope formula is change in y divided by change in x. So what I'm going to do here is I'm going to figure out my change in x's and change in y's and then do my fractions. So as I look at this table, my x's are on top, so I want to notice my change in x's. So I start at one number, I go to the next number. This is a change in x, so my delta x would be adding 3. From 0 to 3 is adding 3. I want to go from 3 to 6, which is also adding 3. I want to go from 6 to 9, which is also adding 3. If I do my change in y, which is the bottom of the table, I want to check the same coordinates that I did. So I did the first and second. So I do the first and second, which is 20 to 11, which is subtracting 9. Then 11 to 2 would be subtracting 9. And then from 2 to negative 7 is also subtracting 9. Now, please understand that these numbers do not always have to match. So the 3, the negative 9, 3, negative 9, 3, negative 9, these do not always have to match, but the rate of change does. That means the change in y from one coordinate to the other divided by the change in x from that same coordinate to the other has to be the same. So I have multiple different changes in y's and changes in x's, so I just have to pick one and see what the change is. And I should double check that my rates of change are always the same. But since all of these numbers are the same, then my rates will be the same. So our rate of change is change in y, or delta y, over delta x. So delta y, change in y, was the negative 9 divided by the change in x was plus 3. So a negative 9 divided by a positive 3 is going to be our slope. Our slope will equal to negative 9 divided by positive 3 is a negative 3. And you can put this as negative 3 over 1 because you do need to understand that the change in y is still over the change in x. But this is our slope from a table. This one was nice because all of the change of x and change in y's were the same throughout the entire table that we were given. If we are not given the same number, we do have to make sure that the rates are the same. So we will do multiple fractions. So if we look at example 2, we want to find our change in y's and our change in x's. So our x's are on the left side, and this one says x and f of x. Now remember, f of x is still the same thing as y, but it is based on the function of x, or the function of f. So that way we could distinguish between different graphs. So finding our change in x, let's go from the left side. So we're going to do the first coordinate from 0 to 2 is going to be plus 2. Then we're going to go from 2 to 8, which is not plus 2, it will be plus 6. So these numbers are not the same, and that's okay for the now, as long as the rate of change, the fraction itself, the change in y over change in x, is the same. Then we'll do from 8 to 12, which is plus 4. So again, not the same. So we're going to have 3 different fractions to double check that all of our rates are the same. Now we have to do change in y. So we'll go from 3 to 6, which is plus 3. 6 to 15, which will be plus 9. And then 15 to 21, which is plus 6. What we're going to do is, over here, we're going to write out all of our fractions. Change in y over change in x. So our first change in y from 3 to 6 was positive 3 divided by positive 2. That is simplified, so our rate right now, our slope is 3 over 2. Now, as long as all of these rates are the same, then that will be our slope. So now we'll do the next one. Our change in y is positive 9 divided by our change in x is positive 6. That simplifies to 3 over 2, which so far they are the same. Our next one is from 15 to 21, so our change in y is plus 6, divided by our change in x is 4, which will simplify to 3 over 2. So all of our changes in x's and our changes in y's were not the same, and that is okay. The rate of change, which is change in y over change in x, this rate of 3 over 2 are the same. These are constant. They're the same rate of change. That means that instead of me doing plus 6, I could have done another plus 2 instead. And instead of plus 9, I could have done a plus 3. And I would have gotten to the same coordinate. It just would have taken a little bit longer. So since all of these rate of changes are the same, this is linear. So we could say that our slope is equal to 3 over 2. Because this is linear, we call this a slope. A rate of change does not necessarily have to be the slope of the graph. The rate of change is just the change of the y and the change of the x for specific coordinates. But since these are all the same rate of change, this would be considered your slope of the line. If we look at example 3, it's another table of x and g of x. And again, g of x is still y. It's the y value of the coordinate, but of the graph of g. So it's just another way of showing a different type of graph. So as we do this, change in x is on top, and change in y is on the bottom of the table. So as we go, we're going to go from 6 to 5, which is negative 1. Then we're going to go from 5 to 7, which in this case is plus 2. So we can already see that these are not the same. And that's okay. As long as the rate of change is the same, we're okay. Then we're going to go from 7 to negative 3, which is down 10. So that's negative 10, or down 10 in value. So that's minus 10. Now we're going to do the change in y. So that is from 5 to 5 is 0. Then from 5 to 5 is 0. And then 5 to 5, which is also 0. So again, we have to double check that all of our rates of change are the same. So we're going to do our change in y over change in x. So our first change in y was 0, divided by our first change in x was negative 1. Well, 0 divided by negative 1, 0 over anything is 0. So this slope right now is 0. Rate of change is 0. The next change in y was 0 over the next change in x was positive 2. 0 divided by 2 is 0. So far, these are both 0. These simplify to 0. The last change in y is 0 over the last change of x is negative 10. So all of these have 0 in the numerator and a normal number or an integer in the denominator. That means that our slope, or this value, all of these simplify to the value of 0. So each of these have the same rate of change. It is a constant rate of change. Therefore, this is linear, and so this is considered our slope. So this says our slope is equal to 0. That means that this, if we were to graph it, would be a horizontal line.